Okay, one more thing we need to talk about. On your page 46, section 6.7. Okay, we finished polynomials for adding, subtracting, multiplying, and dividing. Okay, and one thing related to those, it's something else called scientific notation. Okay, so let's see, what do we mean by that? We talk about poly times poly, right? And if just one term for multiplication, we did all those, we have an times an, right? One term times one term. So product property, right? You add your powers. If it's a division, one term divided by one term, you subtract your powers, right? We call it quotient property. And another one, power on power, same base, right? We multiply our power. We call it power property. And if we have two things multiply together, a product, take a power, then we need to distribute our powers, right? Because this is a power of a product, right? If you have two things, a over b to the nth power, you need to distribute your power as well. Of course, the denominator cannot be 0, right? We'll call this power of a quotient, right? And we also have a 0 exponent, right? A to the 0 power is 1, and base we don't use 0. So we call this 0 exponent, right? So we are going to use those ideas to do something called scientific notation, okay? Before we do that, inside this scientific notation, we use something called negative exponent. Right? So far we talk about polynomials, and they are all what? Poly, many terms. For each one, each term looks like this, with a coefficient n x to the power, but n is what? Positive or 0. That's for polynomials, right? We didn't use the negative exponent for the polynomials, right? But we use negative exponents for something else. All right. So let's see. We say, if we write it this way, if we say 2 negative 1, when we have negative exponent, it doesn't mean negative. This negative is not real negative numbers. It's just a symbol, means what? A reciprocal. Okay? Writing in fraction form is 1 to the 1 power means this guy, 1/2. Okay? If we have x negative 3, it means what? You interpret the negative symbol first, become the division reciprocal, you change it to the denominator instead. It means 1 to the x cubed. Okay, so negative exponent means what? It means it's reciprocal. It means this way, if a to the negative n power, it means what? 1 over a to the nth power. Okay? Of course, base, we don't use 0. If we say 1 over a to the negative nth power, it means what? Reciprocal to this, it becomes what? Regular, right? A to the power. That's the negative exponent mean. All right. So, if we have this thing, let's take a look on this. So, if we have a situation like this, if we have x squared divided by x6 power, right? So according to our rules, besides we used for all the positive exponents, all those things also can be used on your negative exponents. Okay, look at your page 46 on the top right hand corner. We described all these rules also applied to the negative things, okay? And if we use these rules, so we say when we divide, we can just do what? Subtract our exponents, right? So it can be 2 minus 6, it can be negative 4, right? But if we do it regularly, it means what? Division. Then if we simplify them, right? So XX, this one is 6 of them. Then because it's a multiplication division, you can cross cancel, right? It ends up what? 1 over x 4th power. We have same question, right? But we write the answer. We write the answers differently. Can we have 2 different answers for the same question in math? We don't do that. Okay? It means we have to have same answers regardless. Okay? It's only would be, one situation for math. So it means what? The symbols are different, but the meanings should be what? The same. Okay? So that's what we are talking about. Negative exponent means what? The reciprocal. Okay? So what we want to do is we want to write it as simple as possible for all those negative exponents, right? So let's see. What kind of things we can make it simpler? Because we cannot really see the negative exponents. So we wanted to write it in, positive exponents to let us to see in general, okay? Except the scientific notation for a reason. So how do we simplify? So usually we will remove parentheses if possible. We don't use that. We write an individual variable with individual powers, right? Then we don't want to show the answer in negative exponents. Okay, we write it in this way so we can see better. At least we know x third means what? You multiply x 3 times. It will make more sense if we write it in what? positive exponent. Okay? So when we simplify, we wanted to do it this way. Let's see some examples first before we write down the steps, how we usually do. Okay, so look at your next page, page 47. So if we have 3 negative 2 power, what kind of number is that? So you will interpret your negative exponent. That would be 3 to the second power. That would be 1/9. That would be the simplest form. Okay. If we have 5 negative 1 power plus 3 to the negative 1 power, don't give me this power, right? We didn't say you can just add the base. When you have negative exponents, okay, you have to do an actual number. So 5 to the negative 1 means what? 1/5. Then 3 to the negative 1 means 1/3, right? Then how do you add the fractions? You have to use LCD, right? Which is 15. So this one times 3 to get a 15, right? This one times 5 to get a 15. So your result should be what? A 15th, right? Don't do those things. We have to do it just like fractions, the way how fraction works. Okay, so next one we have is what? Negative 3 to the negative 2 power. Negative 2 power means what? Reciprocal, right? But this negative 3 is a real number, 3, which is a negative. So it's a whole base. If you change it to reciprocal, it should be what? The whole base take the second power, right? Then negative 3 times twice will be what? Positive, negative, positive 9. So that would be the answer for this. Okay? If we have this one, 1/7 negative 2 power, then it's like this. You have to write it in reciprocal, then it's second, you flip to the top, then you remove your negative, right? It should be what? 49. So when we simplify, we want to write everything in the positive exponents, right? So what do? If it's a positive, you keep where you are, right? If it's a negative exponent, what do? You have to flip, right? So we will do this. We will keep the variables with those positive exponents, right? And we will flip those variables with what? Negative exponents, right? Then we simplify. Consolidate them, not too many x's everywhere, not too many y's everywhere, right? We just write a single variable with its own powers. So write the simplest form that way, okay? So if you look the examples, 7x to the negative 4th power, how will we write? 7 means 7, right? But x to the negative 4th power would be what? 1/4. x to the 4th power, right? Then when you multiply, how do you do? Usually you put 1 underneath, you multiply straight across, you should have 7 to the x 4th power over, right? That means if you don't have a positive or negative power, it means positive, right? Then you keep on the numerator position. If it's a negative power, you flip to the other side, to the down. If it's on the top, nothing here means on the top. Then you flip to the bottom, right? If we have 1 over y to the -7, it means what? It's on the bottom. You flip to the top, that will be what? Y to the 7th power. Okay? That's how we simplify. So we want to write everything simplest form, each individual variable with its own power. Then write all the answers in the positive exponents. Okay? So this one was negative. So this one we need to flip. This one we need to flip. It will end up this way. Right? Then if we have x over x -4th power, do we flip this x? We don't, because it's now negative. Then x -4th, we need to flip to the top, become this way, right? Then too many x's, right? Then we need to consolidate them. This one means what? Invisible one of them. So total will be what? X 5th power. That's how we make a simplest form, right? Okay, and let's see, next one, 7z -2 power to the z 4th. So do we flip the 7? No. Do we flip this z to the -2 to the other side? Yes, because negative exponent, right? Once you flipped, then the negative exponent is gone, right? So z to the 4th power, do we flip? No, it stays. So total would be what? Z to the how many? Would be 6. Right? Okay. So for variables, we do that. Keep the variables with positive exponents, at their own place. Then flip the one that is not, it's a negative exponent. Okay. Another thing is you can look at this 2/3 to the -3. You have several ways of doing it, but one of the simplest way is this way. But the inside is a fraction. But since this one is this, instead we do 1 2/3 to the 3rd power, it gets complicated, right? So what we need to do, it's okay, but complicated, right? So we can do a simpler way is what? Since this is negative, means what? Reciprocal. We can just interpret this to the inside. What's reciprocal? 2/3 would be what? 3/2. Right? We can just do that directly. Then you multiply 3 times. That would be 27/8. That would be easier. Okay, instead of doing this way, you multiply, then you divide again. But that way still work. Right? Because it would be what? 1/3 times is a to the 27, right? And it means what? This big line is division. It becomes very complicated. 1 divided by 8/27. Then you have to flip multiply 27 to the 8th, you get 27/8. You still get the same answers, but it's more complicated. Okay, we can just directly do it this way for numbers. All right, let's see. If we have this A, -4, B, 7, and -5. So what do we do? Individual variables, but too many powers on each one. So what do? We just remove the parentheses if we can. Then, as we say, you have two bases for power, and you can do what? You can distribute the power to each individual thing inside, right? So you have -4 to the -5th power and B7 to the -5th power, right? Then you write it. So power on power, you use power property, you multiply them. Then this one is B -35, right? But we say we don't leave the answer in a negative exponent form, right? So we will write the answer which way? A20 stays, B35 move. That would be the answer we would do. All right, next one. So we have this one, 9x cubed to the y to the -2 power. Right? There are many ways. So if we do this way, like this, okay, method 1, we can do it because it's a reciprocal. So because it's a fraction, we can just flip. Becomes what? Y over 9x cubed to the 2nd power, right? Then you distribute to everything inside, 3 things inside. You need to apply 2 to all of them. That will be what? Y squared and 9 squared x cubed to the square, right? Then we cleaned up, would be what? Y squared, 9 squared is 81, x3 to the 2nd would be 6. That's how we simplify them, right? Or we can have a method 2. Okay, so you don't have to remember if fractions, you do the reciprocal first. We can just do it same way, like this. Remove the parentheses individually, then write it out, then go from there, right? So we distribute to -2 to everybody. So you have what? 9 to the -2, right? Then x3 to the -2, right? Then y to the -2. Then we write what? Before we flip, we write an individual variable with its own power. So 9 to the -2, x to what? -6, y to what? -2, right? Then we flip the things with negative exponents. So what do we have? We flip this 9 to the square, x flip to the 6, y flip, y to the square. So you have final answer is y squared, 81x to the 6th power. Do we have the same answers? You can do either ways. Okay, so let's look one more. Next one is 3x -2, y -2 to the 4x7y. Okay, so easiest way is just write it individually with its own power. Then do the flipping. right? So that's kind of straightforward that way as well. So that's one way to do it for all the problems. You can just do that. So we have what? 3 things for the -2. So you write a 3 to the -2, x -2 to the -2, y -2, right? Here is this one, right? Okay, then what do we have? 3 to the -2, x to how many? -2, -2 multiplied 4, y -2, 4x what? 7 to the and y, right? Then individual variable with its own power. Now we don't write it in negative exponents, right? So we flip them for the things you need to flip. 3, -2 flip, x4 stays, y -2 flip, right? How about those? 4 stays, x7 stays, y stays. Is that right? So what do we have? X to the 4th power, 3 to the 2nd, 9. 9 times 4, 36, right? Then x7, y how many? Y 3rd, right? Do we leave the answer there? Why or why not? You still have x at the 2 places. We don't want to do that. One variable, one place, okay? And one with its own power. So those can be canceled to what? Only 3 left, right? So the answer should be what? Should be, that's 1, right? Should be 1 over 36 x 3rd, y 3rd power. So that would be your answer. Okay? Then let's look some scientific notations. What kind of things we say they are scientific notations? It's a certain style and certain notations. Okay? So let's talk about power of 10. That's what we use in science. Okay? So we know 10 to the 0 power is, anything to the 0 power is 1. 10 to the 1 power is what? 10, right? 10 to the 2nd power is what? 100. And 10 to the 3rd power is what? 1,000. How many powers? And how many power? Then you will be how many zeros behind it. Okay? Then we just learn 10 to the -1 power means what? Reciprocal. It means what? 1 to the 10th, which means what? 0.1, 1/10. All right? 10 to the negative power means what? 1 to the 10 to the 2nd power, 100th. Right? So 100 means what? 100th position. 10 to the -3 means what? 1 to the 1,000, right? 10 to the 3rd power, which is what? 1,000th. Then will be 0, 0, 1. Right? -3 to the 3rd position, -2 to the 2nd position, -1 to the 1 position, 1 decimal. Right? So that's for the 10th power. For the 10. Okay? So then scientific notation is this way. We are going to write some numbers times 10 to a power. Okay? So this style we call it scientific notation. You write some number here and some power, 10 to the some kind of power. Okay? So power can be what? Positive or negative. and 0. So R is an integer. Okay, means what? 0, 1, 2, 3, or -1, -2, all that. Okay, whole numbers with positive and negative. And when you write a scientific notation, this number is a special kind of number. It's between 1 and less than 10, means what? 9.9999, all this kind of number. Not 10, 2 digit. Only 1 digit. Okay, 1, 1.11, 1.1111, right? Only one number in front of the decimal point started from 1, not a 0 point something. You have to have something in front of the decimal point. Okay, those kind of things we call scientific notations, from 1 to 9.9999 something, and multiply by 10 to a power. Okay, so what we will do? We will identify things. They are scientific notation or not. Okay, first we identify them. Then we do operations on them. Okay, so if we see this one, 3.28 times 10 to the second power, is this a scientific notation? 3 is between 1 and 9.99, between 1 and 9, right? Then with decimals, decimal points, yes, and 10 to the power, either positive or negative. Okay, if we have 42.1 times 10 to the 6th power, is that scientific notation? No, because you have 2 digits in front of your decimal point. Okay, it can only have 1, so this one is no. We don't want to write it this way. And if we have 6.1 to the negative 10 to the negative 3rd power, what do you think? It is. Okay, and if we have 0.378 times 10 to the 5th power, is this a scientific notation? No, because there's nothing before the decimal point. You need to have at least 1 there. Okay, so those type of things, we call them scientific notations. So if you look at the page 48, how we use them. Okay, so if we say speed of light is this way, 983.569.000, right? And per second, it's the speed of the light. It travels, you blink here, it travels so far away, so many feet away. For the accuracy, how will we write it? We want to know actually how big it is, means how many zeros there are, so we know how big the number is. So we write it this way. To write it in scientific notation, what kind of number we have to put it here? Times 10 to the 4th power, right? So you can only use one number in front of the decimal point, so you have to put your decimal point here. So you put the 9 here, but you still need all the numbers you use, right? So you put all the remaining number behind it. Then you have to decide how many powers, tens of power you have to multiply. So it was here, you move how many places? 1, 2, 3, 4, 5, 6, 7, 8. 8 places for the decimal. So you have to put a positive 8 or negative 8 there. Then you have to decide. From the smaller number turn into the bigger number, you have to multiply positive number to become bigger. If it turns smaller, then you multiply a negative number. That's how it works. Okay, so we do this for accuracy. Say, if Amazon make so many dollars per year, right? So if you short a 0, does that make a big difference? This is 1,000. This is what? Million, billion, trillion. Maybe a year they make a trillion, right? If you short 1, then it become what? 100 billion. It's a big difference, right? So how would we write it? In the scientific notation, we do what? 1, that's 1, times 10 to the how many powers? You count how many zeros there are, 12 of them. And you know, you put a 12 power, then you know there will be a 12 zeros there. So you know exactly the numbers better, okay, for the accuracy. All right, then next one, biology. So we are going to skip it. Okay, so if you have questions, we can work on that. Now let's take a look how we convert back and forth between regular numbers and scientific notations. Okay, regular numbers, we call them standard numbers. Okay, so if I have 3.2 times 10 to the third power, do I have a scientific notation? So you times 10 to the third power 1,000, the number should be bigger or smaller? Should be bigger, right? If it's bigger, you move your decimals to the right or to the left. Bigger, then you move to the right. How many positions? If it's 3, you move 3 times. So the answer, empty space, you should put a 0 there, right? Put a 0 here. So it's 3,200. That's how it works. So let's just change the scientific notation to a regular number, which is a standard number. So for this one, when you multiply -3 means what? You multiply by 1,000th. Multiply a small number, so number becomes smaller. Okay, so you have to move your decimal to the right or to the left. Become smaller, you move to the left. So how many places? Whatever the power is. So 1, 2, 3. So your new decimal will be here. Then for the empty space, what do you do? Fit in with 0. So your answer should be 0.0056. Right? If you look at the next one, 4.29 times what? 10 to the 0 power. 10 to the 0 power means you move left or right or nothing. You don't move, right? That means what? 10 to the 0 power actually is 1. 1 times this is this guy, right? You don't have to move to anywhere. So, for the scientific notations, we can change the scientific notations to the regular numbers. Okay. And we can also change the regular numbers to a scientific notation, right? So, which number you should put it here? We can only use one decimal, one number, one digit before the decimal point, right? From 1 up. So it's a 3. So you have to put a 3 here and decimal. Then you just don't leave the number only 3 there because you have other things. It's also, you know, valid. You need to use it. So you have to use every one of them. So which number is bigger? This one's number is bigger. This one is smaller. So from smaller to bigger number, you have to multiply 10 to the power positive or negative. From smaller to bigger, you have to multiply big number for it. So it's positive power. Then how many positions did you move? It was here, you moved to here, right? So how many? 1, 2, 3. So you need to do 3 there. Right? If you multiply it, you will go back. And next one is 0.01436. Okay, you have to write it like this somehow. So, which number you do need to put here? You have to have 1 digit above 1, right? So you need to put 1.436. So which number is bigger? 1.436 is bigger than the original number, right? So you need to multiply by what? A negative power, because from bigger number to the smaller number, then you need to multiply a small thing to get there. So how many positions did you move? 2. So it's -2. Right? So we just write the things in a scientific notation style. Okay, first we identify them, then we can convert them back and forth with regular numbers, which we call them standard numbers, then to scientific notations, right? At the same time, we can use those to multiply and divide this way, okay? It's easier to operate on with scientific notations. Instead, you have small number 0.00008 times 7,000, right? Then you have to do your decimals, cancel your zeros, you know. This way we do it with scientific notations will be much easier and for the accuracy as well. Okay, so 8 times 7, 56, right? 10 negative 6 power times 10 to the third power, right? Do we have am times an same base? Then we just add our power. So 10 to the how many power? Negative 6 plus 3 is -3, right? Then we can write the final answer in a regular style, a standard number. So becomes smaller. So it was here, so we move how many times? 3 times. So your answer should be what? 0.056, right? And much easier than doing this 0.000008 6 times moved. Then times what? 730. Then you multiply them, you line up your decimal points, right? Then it becomes complicated, right? Just review your decimals. Okay, how to multiply. You do what? 7,000, right? Then 000, 56, right? Then how many decimals, decimal points do you need? You count it. 1, 2, 3, 4, 5, 6. 6 here, nothing here. Total you need 6. So you will 1, 2, 3, 4, 5, 6. Right? So that would be your answer. Then you don't use those zeros. You don't need it. So you get the same answers. Okay? But if you didn't line up, you miscount, would be less accurate and instead of using the scientific notation. Okay? So it's for accuracy and for convenience. So we use those scientific notations in the science field, naturally, right? Then if we have this, what do? We cancel out this, right? Then what do we have? Then we have a 2 here, then 10 to the second power here. Then 10 to the negative 3 means what? Reciprocal. You do reciprocal will be 10 to the 3 power, right? Nothing here anymore. Then what do we have? So we will have 2 times 10 to the how many powers? 5. You add your power, right? So final answer would be what? 5 zeros. 1, 2, 3, 4, 5. Like this. Right? Much easier and as accuracy as well as for the accuracy. Right? So that would be our section 6.7 for the negative exponents and scientific notations.